Hello everyone, welcome to this video on AWS Load Balancer. Today I'm going to explain how AWS Load Balancer help distribute traffic across your application and why they are super important for modern cloud-based solutions. Whether you are managing a small website or a high traffic application, load balancing is something you can't ignore. So let's get started. Okay, so first, what is load balancing? Simply put, it's like having multiple counters at a ticket booth. Instead of everyone rushing to a single counter, traffic gets distributed evenly to all available counters. This ensures no single counter gets overloaded and all customers are served efficiently. AWS provides something called elastic load balancing as a managed service. It's super easy to set up, integrates with other AWS services, and provides benefits like fault tolerance, low latency, and a smoother user experience for your cloud applications. Now, AWS offers four types of load balancers, and each is designed for a specific type of traffic and use case. First, we have the Application Load Balancer or ALB, which is perfect for modern web applications. Next is the Network Load Balancer or NLB, which is for ultra low latency and high throughput needs. Then there is the Gateway Load Balancer, which is used to manage third party appliances like firewalls. Finally, we have the Classic Load Balancer, which is for older legacy applications. So, the application load balancer operates at the application layer, layer 7 in the OSI model. This makes it ideal for HTTP and HTTPS traffic. So you can route traffic based on the URL path like login or API, or even based on the domain name. It also supports WebSocket and integrates with AWS Web Application Firewall, additional security. Moving on to the network load balancer. This works at layer 4, which is the transport layer. It's designed for TCP/UDP and TLS traffic, and it is super fast, like lightning fast, because it uses static IPs and can handle millions of requests per second. It's a great choice for things like gaming or financial applications where speed is everything. Now, the gateway load balancer is a bit different. It combines load balancing with gateway functionality and operates at layer 3, which is the network layer. It's mainly used when you are deploying virtual appliances for things like traffic inspection or firewalls. It simplifies how you scale and manage these appliances. The classic load balancer is well classic. It's one of the original options from AWS and supports both layer 4 and layer 7. But compared to ALB and NLB, its features are quite basic. It's mostly used for legacy applications that don't need the advanced features of modern load balancers. Here's a quick comparison of all four types. As you can see, each has its strengths. ALB is for advanced routing and modern applications, while NLB focuses on high performance. GLB is for managing appliances, and CLB is for older workloads. Choosing the right load balancer really depends on your specific needs. Let's talk about some common features. All AWS load balancers come with health checks, so they only send traffic to healthy targets. SSL termination simplifies security setup and they automatically adjust to traffic changes with autoscaling. Plus, they work seamlessly with other AWS services like EC2, ECS, and Lambda. Now, where would you use these load balancers? ALB is great for microservices and apps with multiple domains. NLP is for real-time systems like online gaming or video streaming. GLB is mostly used in security-heavy environments, and CLB that's for legacy systems. Okay, a quick note on pricing. AWS load balancer costs depend on usage, the amount of data processed, and connection request. For example, using ALB for a medium-sized application might cost around $20 to $50 a month. Remember, cost can add up if your traffic is high, so keep an eye on your usage. So, what are the advantages of AWS load balancers? First, they provide high availability with automatic failover. Second, they scale up or down automatically to handle variable workloads. They also support global traffic distribution, making them perfect for multi-region deployments. And finally, they are managed by AWS, so setup and monitoring are super easy. Let's look at some challenges. Configuring health checks properly is must. Otherwise, traffic might go to unhealthy targets. Also, keep track of costs, especially if your traffic fluctuates a lot. And remember to use the right load balancer for your application's needs. This image is an architecture diagram illustrating a basic setup of AWS load balancer. The diagram starts with an user icon representing an end user who is accessing the application. The user connects to the application load balancer through an internet gateway, which allows communication between the VPC and the internet. The internet gateway routes the traffic to a load balancer, which distributes incoming application traffic across multiple targets, such as EC2 instances. The entire setup is within a VPC, which is a logical isolated section of the AWS cloud, where you can launch AWS resources in a virtual network that you define. Inside the VPC, there are two Amazon EC2 instances. Each instance is within its own subnet. The first EC2 instance is in the subnet with the CIDR block 12.0.1.0 bar 24. The second EC2 instance is the subnet with CIDR block 12.0.3.0/24. Both EC2 instances are part of a target group which the load balancer uses to route requests to one or more registered targets. The entire VPC has a CIDR block of 12.0.1.0/16, which defines the range of IP addresses available within the VPC. Now, let's dive into the hands-on. Okay, let's follow this architecture step by step. First, we need to create a VPC. Go to VPC, click on Create VPC, and here I'm creating VPC named LB VPC1 with the CIDR. Now, let's verify that. Yes, VPC has been created. Next, next, we need an internet gateway to connect our VPC to the public internet. Now, go to Internet Gateway, click on Create Internet Gateway. I'm going to name it LB Internet Gateway 1. Click on Create, and now we need to attach this Internet Gateway to our VPC. Select our VPC, attach. Now, let's create two subnets. Open subnets and click on Create Subnet. Select the VPC, and first subnet name will be sub1. Availability zone, I'm going to select West 2A, and IPv subnet CIDR is 12.0.1.0/24. Then add new subnet because we need two subnets. For this, will be sub2. Select different availability zone to be And for this, the IPv4 subnet CIDR block will be 10.0/24. And that's it. Click on create subnet. Now two subnets has been created. Now we need to create a route table to allow internet access for this subnets. So click on create a route table and give a name on and select the VPC. That's it. Create. So now we need to associate subnets to this route table. So edit subnet, select all, save associations, and that's it. Subnet has been created, associated, and now click on routes and edit routes, add routes, select 0, and internet gateway to access internet gateway. And that's it. Finally, we add a route to the internet gateway within this route table. After creating two subnets, now we need to create two EC2 instances. Now go to EC2 instance, launch instance, there will be EC2 one. For the first instance, I'm choosing a 1 2. Then T2 microfilter, and I'm going to select existing keeper. If you have existing keeper, you can select that and click on edit in network settings. Select the LBVPC 1 VPC and subnet. I'm going to select first subnet and don't forget to enable the auto assign public IP. Now we have inbound security rules SSH to here we have access to SSH port number 22, but we need to add another rule for HTTP. So select HTTP for port number 80 and go to advanced details. In the user data, I'm using user data to install Apache and configure the index.html page to display the instance host name. Now I'm launching the first instance. And that's it. First instance has been created. Now I'm following the same steps to launch the second instance. Here we need to select different subnets. Once both instances are running, I'm verifying that Apache is installed and accessible on the each instance. So I'm going to copy the IP address, opening new tab. You can see here, and for second one, both are running successfully. After creating EC2 instances, now let's create a target group. Now, in the load balancer, go to target group, click on create target group. Default, I'm choosing instances, and the name here will be target group 1, and I'm selecting VPC will be VPC1, and that's it. Click on next, and I'm selecting both the instances. Click on include as pending below and create target group. Now you can check here, target group has been created, and you can monitor the health of these instances. Now we have a target group ready. After creating target group, finally, let's create our application load balancer. Click on load balancer, create load balancer, select application load balancer, create, give a name. I'm creating an internet facing application load balancer and select our VPC. I'm selecting both our public subnets and click on create new security group. Here I'm creating a new security group to allow HTTP traffic on port number 80. So that's why I'm creating a new one. Copy this name, and here you can choose this. So here I'm selecting default security group and LBSG demo for allow HTTP port number 80. Here you can see summary of the application load balancer. Now status is showing provisioning. So we need to wait for a few minutes. Once the application load balancer is created, we can access it using its DNS. And the status is showing active. To load balance and copy the DNS name. Open new tab and paste it over here. You can see here it's running. Application load balancer is successfully distributing traffic between our two EC2 instances by changing IP addresses. And there you have it. We have successfully created an AWS application load balancer and configured it to distribute traffic across multiple EC2 instances. This is a fundamental building block for many scalable and fault-tolerant applications in AWS.